we will look at the eigenvalues and eigenvectors of square matrices. Okay, and then further we will see characteristics polynomial of a square matrix. So as per the definition is concerned, let A be any square means the same number of rows and same number of columns. So here I have assumed n cross n square matrix, and X be any vector in Rn written as a column vector. Okay, then the matrix product AX again is a column vector in Rn, right? This is very simple. If you have, let's say, n cross n, and if you have a vector of n cross 1, then what is the product? Product will be n cross 1, because column and row will get cancelled. So this is n cross 1, right? So due to the property of that, due to property of product. Okay. Now let A be a square matrix, and a scalar lambda is called an eigenvalue of the matrix A if there is a non-zero vector x in Rn such that this equation holds Ax equal to lambda x, where x is non-zero vector. Okay. Every non-zero vector x satisfy the above equation called an eigenvector associated with the eigenvalue lambda, right? So we are basically searching all such vectors which satisfy this equation, then we call it as lambda is an eigenvalue and x non-zero vector x as an eigenvector corresponding to that lambda. Okay, so let us see some examples. Let A be a zero square matrix. Okay, then 0 is the only eigenvalue of A, because x I want non-zero, x I want non-zero. So Ax equal to lambda x, and A is zero matrix. So left hand side is 0 and right hand side is non-zero. Then how am I going to get equation satisfy? Only provided lambda equal to 0, right? So 0 becomes, this becomes 0. So the zero matrix, a square matrix, has eigenvalue 0. And every non-zero vector x is an eigenvector associated with the eigenvalue 0. So all non-zero vectors x forms and I called an eigenvector associated with the eigenvalue 0. Let us see another example. Let A be an identity matrix, then 1 is the only eigenvalue of A, right? Because identity matrix of the form, like let's say if I say 3 by 3, right? Then any vector, if you take x, right? Let's say x1, x2, x3, where x is a non-zero vector, right? A is your matrix 3 by 3, okay, equal to lambda x, lambda and then x. So what is the only possibility? Because whenever you multiply, you will get 1 and then you will get 0 and then you will get 0. So first element will be 1, and then again if you see, you will get second element 0, second get multiplied by 1, and then so you'll get a column vector like lambda times what is the possibility of that in that case? Lambda. So lambda is only 1, right? So every non-zero vector x is an eigenvector associated with eigenvalue lambda. Whatever the value of x you are going to choose, if I say I'm going to get multiply lambda as 1, so lambda x, x1, x2, x3, because whenever you get multiply, you will receive the same vector x, right, with the identity matrix. Similarly, if you see a matrix A of having a special kind 1 1 1 1 all entries, then it is easy to see that A into 1 minus 1 is equal to 0 0, and then we can write it as 0 times 1 minus 1. So 0 is an eigenvalue of this matrix. Okay. Similarly, and 1 minus 1 is an eigenvector associated with the eigenvalue 0. Similarly, if you see A into 1 1 can be multiplied. When you multiply, you will get 2 2 in the column, right? Then you can write 2 times of column 1 1. In that case, 2 is another eigenvalue of the matrix A with corresponding eigenvector 1 1. Okay. So now look at it. We are going to learn how to find the eigenvalue eigenvector, right? We have seen with some trivial examples. Now we are going to consider the characteristics polynomial ax equal to lambda x. Now I'm going to take left hand side ax minus lambda x is equal to 0, and I'm going to take a x common, right? A, if I'm going to take a minus lambda, identity matrix of the same size x will be 0, and this equation says x non-zero, then what is the guarantee? This factor must be 0. So a minus lambda I is equal to 0. 0 bar means 0 vector of Rn. Okay. So hence lambda is an eigenvalue of the matrix A if and only if the above homogeneous system, this system you can consider like B x equal to 0 type, right? So this system has non-trivial solution provided if the determinant of B is 0, right? Then you will get infinite solution or non-trivial solution. If B determinant of B is non-zero, then B inverse will exist, and if you multiply B inverse both side of this equation, then you will get only 0 0 0 solution, which is a trivial solution which we don't want. Okay. So now this homogeneous system has non-trivial solution or non-zero solution only if this determinant of this value is going to be 0, a minus lambda is 0. So now if I'm talking about the in more expressed way, so now if you see a minus lambda, identity means all the diagonal entries, so get it multiply by minus lambda, so it's a scalar matrix. So a minus lambda identity, this determinant we are going to write. So this is a11 minus lambda, a12 and so on, a1n, a21, a22 minus lambda and so on. All diagonal places are subtracted by lambda. Okay, and that determinant is going to be 0. So now this equation on expression gives an nth degree polynomial and equation in lambda called characteristics polynomial or characteristics equation, right? The determinant of the coefficient matrix A, determinant of A minus lambda I n is called characteristics polynomial of matrix A. So hence an nth order square matrix can have at most n eigenvalues, right? At most, I mean sometimes this eigenvalues are going to be repeated, so they are going to be like or some of them are going to be 0, right? So let us see one example. Find the eigenvalues and eigenvector associated to the square matrix. So now we have to solve A minus lambda I 3 cross 3 because A is 3 cross 3. Okay. So A minus lambda I. So lambda I looks like, what's the picture of lambda I? It will looks like minus identity matrix multiplied by lambda. So lambda 0 0 0 lambda 0 0 0 lambda. So this is lambda I basically. Okay. When you subtract it, only lambda will get subtracted, right? So this is how you are going to get the stuff. Okay, so now the characteristics equation is nothing but this, and determinant must be 0 as per the definition. So now once you solve these equations, you just find the determinant. You know, finding determinant this, then you multiply this and minus this, then take negative sign, positive, negative, positive, and then you take the minor coefficient, this into this into this, and then similarly for this into this into this, right? This into this minus this into this. The determinant, you know how to find out, right? So determinant, we are going to figure it out. So after solving this determinant, we are going to get the polynomial, this equation as a polynomial in lambda of highest degree 3, right? So in that case, you can say this is a characteristic polynomial of the given system, right? Of the given matrix, you can say. So when you solve it, you will find lambda equal to -1, 2, and 4. So there are three distinct roots corresponding to that matrix. So these all are called eigenvalues. Now regarding eigenvectors, so since all of them are distinct, so we have to solve for each of them individually. Okay. So for lambda equal to -1. So lambda equal to -1. So a minus lambda I is equal to 0. I have to do, right? Determinant. So a minus lambda is already -1 and identity, right? So what exactly it happened? A plus lambda, a plus I is equal to 0, which is this a plus I3. I is here 3 cross 3. Okay. Since x is non-zero, so this system we have to solve. So this system means you have to solve in the matrix and then replace the coefficient, subtract -1 from the diagonal of the original system. So you will get this system. Now we have to solve this system using RREF method, reduced row echelon form method. So what we are going to do it, we are going to have 3, 2, 3, 1, 3, 1, 1, 2, -2, and 2. So first of all, we have to target first row, first column element, which is not 1. We need 1. So we need to see any row is having 1, then we can swap it. So you see R1, R2, R1 swap to R2, R2 swap to R1. So I got this is a pivot element. Now we have to make 0 3 times, 2 times using this operation, elementary row operation. We got reduced to this. So now first column is job is over. Now we move to the second column, lower row. Second column, lower row is -7. We want to make it 1. So we have to multiply by -1 by 7 to the row 2 to get 1, which is we have obtained. And after getting 1, we will use the elementary row operation to make it 0 to this candidate, right? -8. And after suitable elementary operation, I got the second entry as also 1. Now if you see the third row last column, third row last column is having 0 element, right? So this is not a pivot element, right? Because we need pivot element as 1. So what does it indicate? The third column. The third column indicates that the variable corresponding to this, let's say if x1, x2, x3 is the variable of corresponding to each column. So x3 is free variable. X3 become free variable. Why? Because no pivot entries are allocated, and then in that case system has infinite solution. So from first equation, x1 plus x3 equal to 0. From the second equation, x2 equal to 0, and x1 is equal to minus x3, where x3 is free. So we can choose any value, as x3 is free. So we can choose any value, and then if you see the x3 0 and minus x3 0 and x3, where x3 is free but non-zero, right? So this is what, why x3 is non-zero, because if you plug x3 as 0, what will happen? Because x3 is a free, it can take any value. So you see 0, 0, 0, and 0, 0 is means your vector x is basically 0, 0 vector, which is not possible in the definition. So to avoid that condition, we need to take x3 is non-zero, right? Because it doesn't work here. Okay. Now we have to solve the same way for lambda equal to 2. So lambda equal to 2 means a minus 2i equal to 0 determinant we have to solve. So we got this system after plugging the value, and similar stuff we have to do using RREF method. So we got this coefficient matrix. Now you see first row, first column element is itself 0. If it is 0, then we have to look on the down column values, any entries are non-zero. If yes, then we will swap the value. If suppose no values are there, suppose 1 and 2 are 0, 0 only, then what will happen? We will not find any pivot entry in the first column, and then hence in that first column corresponding variable will be free variable, x1 become free variable. But this is not the case because below there are non-zero entries, so we have to swap it. R2 R1 if we do, we got non-zero pivot entry, and then we have to make it 0 to the below. So only this column we have to make 0. 2 times of R1 we have to subtract from R3. So we are going to get this element. Now again we have to make this next row, next column 2 to make it 1, divide by 2 to the second row using elementary operation, and then we got into the this way. So 2. And then again the case in this column we are not going to get any pivot entry, hence what we can say, this row corresponding to this row variable is free, and infinite solution case will occur. Okay, after solving this we are going to get x1, x2, x3 and so on. Here similarly in the similar case, here also x3 will not be non-zero, right? So this is the second eigenvectors corresponding to eigenvalue lambda. Similarly, we have to solve for lambda equal to 4. So we got solving using system of equation again, a minus 4 lambda I, and then we got the system, use RREF. Then same practice we will do. We have to see how it can be solved. So divide first or multiply minus 1 by 2 into the R1 to get 1, 1, minus 1 and minus 3 by 2. So this is first row, first element become your unit element. You can also see, you can swap it first row, second row as we did before, because this is also unit element, but there are several ways of doing it, so we have done using this method. Okay, and then you have to just simply subtract 1 time, 2 time from R2 R3, so you will get 0 0 in this. Okay, then you have to again take this element because we have to get it into 1, so you need to multiply by minus 1 this row, so you got 1, and then since already it is 0, so this 2 pivot entry we got, and third is again free, so free variable we will get here, and then solve using the system. So what are the solutions? Solutions are this: free variable but x3 is non-zero, right? So these all are done. Thank you.